Okay, what we're going to look at today, and again, this is something else you need to memorize. If f, this is the intermediate value theorem. This is very, very popular on the AP exam. So intermediate value theorem. And I just abbreviate theorem with THM. Intermediate value theorem. So here's what the intermediate value theorem says. If f, a function, is continuous on the closed interval from A to B, the closed interval being the x-axis. So this means x-axis, some x value A, some x value B, and K is any number between f of A and f of B. F of A and f of B being y values, the y value at A and the y value at B. Then there is at least one number C in A to B such that ST is such that f of C equals K. Alright, I know that sounds long and complicated. It really isn't. I almost call it the no-duh theorem, or the no-duh theorem. So what I'm going to do is I'm going to draw you a graph. It makes much more sense if you look at it graphically, okay? So if I give you some value here, or some function there, okay? And we're going to call this point A, or that x value A. And of course my y value then is f of A. So my point there would be A, f of A. And then over here, we're going to call this x value B. So that y value being f of B. And then I'm going to say C, this is C, and f of C or K. F of C or K, like it says here. So this is f of C. So what this theorem literally says is that if f is continuous, so meaning if my function is continuous, well, is it? Yes. On the closed interval from A to B, so between 2 points, A and B, they can really be any numbers. And K is any number between f of A and f of B. So f of A and f of B, K being my y value. Then there is at least one number C between A and B such that f of C equals K. Basically, what it means is that if I have 2 points, there has to be, or if I have two values, two x values, a range of x values, there has to be a point between those two values. Okay? There has to be able to be something in the middle between these two y values. Okay? Now, this is one you need to memorize. It is very, very popular on the AP exam. here's what we're going to do with this. We're going to use and from now on I'm going to refer to intermediate value theorem as IVT. Use IVT to show f of x equals x cubed plus 2x minus 1. Sorry, that should be x cubed. Has a 0. In the interval of 0 to 1. Okay, so here's how that works. Alright, so for f of 0, we're going to find out what f of 0 is. Alright, we're plugging in my two interval endpoints. So, plugging that in, I have 0 cubed plus 2 times 0 minus 1, which is just negative 1. So I know that f of 0 equals negative 1. Now we're going to plug in my other endpoint, 1. So f of 1 equals 1 cubed plus 2 times 1 minus 1. Alright, well, 1 cubed is just 1, plus 2 is 3, minus 1 is 2. So I can now say that f of 1 equals 2. Therefore, now this is actually, that is just your word to show your answer. This is your actual answer. It follows. Sorry, it follows. Follows that f of 0 is less than 0 and f of 1 is greater than 0, then by the intermediate value theorem, there must be some c, c again being an x value, in the range from 0 to 1 such that f of c equals 0. One more example. All right, we are going to verify the intermediate value theorem applies to the interval and that f of c equals 6 in that interval. So, we're going to say this is our problem. F of x equals x squared plus x over x minus 1. And we're going to do this from 5/2 to 4. And we want to prove that at some point in that interval, f of c will equal 6. So, first thing I'm going to do, as I did before, I'm going to plug in my endpoints. So we're going to find f of 5/2. Now you don't necessarily have to have a calculator for this, so we have 5/2 squared plus 5/2 over 5/2 minus 1. Well, that is 25 over 4 plus 5/2 over 5/2 minus 1. Doing my algebra there, I get 25 25 over 4 plus 5 halves. Well, I can actually rewrite 5 halves as 10 fourths. And I can rewrite 1 as 2 over 2. So 25 fourths plus 10 fourths is 35 fourths. All divided by, well, 5 halves minus 2 halves is 3 halves. Well, fraction divided by a fraction. Remember, you keep the same one the same, 35, or your numerator the same, 35 over 4. Change division to multiply. Flip your fraction into 2/3. Cancel. All right, again, multiplying straight across. I can cancel my 2 here, and 2 goes into 4 twice. So I then have 35 over 6. All right, which roughly, if you type that into your calculator, well, 6 times 6 is 36. So that is about 5.8. So that's less than 6, right? And we are wanting to prove that this equals 6, that at some point my y value has to be 6. So now we're going to do f of 4. We have to plug in my other endpoint. So 4 squared plus 4 over 4 minus 1. Well, 4 squared is 16 plus 4 over 4 minus 1. 16 plus 4 is 20. 20 over 3, which is roughly 6 2/3. 6 2/3 or 6.66 repeating. Okay, now for my justification, and again, AP requests these things. Intermediate value theorem always shows up. So we're going to say it follows, and I'll do my justification on the next page. It follows that f of 5 halves is less than 6, and f of 4 is greater than 6. Then, by the intermediate value theorem, IVT, there must be some value C such that not such that in the interval full from 5 halves to 4 such that f of C has to be equivalent to 6.